2, powers and exponents. Now, a lot of students think that powers and exponents mean the same thing, but they're not the same thing. I'm going to kind of try to make sure you know which is which and differentiate between the two. Definition: a power is not the actual little number raised to the right. A power is the result of a repeated multiplication of the same factor. Now, when we have addition that's repeated, 5 plus 5, 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. That's a hassle to write out in that long expression. So with repeated addition, we use multiplication. We have 1, 2, 3, 4, 5, 6, 7 terms, 7 addends of 5. So we write this as 7 times 5 because multiplication is for repeated addition. Well, we use the idea of repeated multiplication as a shortcut. We use the idea of an exponent, and repeated multiplication is a power. Now, there are two parts. As you can see with my example over here, I have 3 with the little 4 up there that you should already be familiar with. And of course, this means you have 1, 2, 3, 4 factors, multiplication of 3. The base is the number that's being raised to that particular exponent. The exponent is the number that's raised and up and to the right and written a little bit smaller. The entire expression, all of this, is a power. So it's not just the 4, it's the entire expression. Now, when we use exponents, we read them off a particular way. As you can see, I have several examples here. 10 with a little 1 raised and to the right is read 10 to the first power. First power, first power. And of course, 10 to the first power means you have one factor of 10, and that's just 10. 4 with a little 2 up there is read 4 to the second power, which I have written over here as 4 times 4, which of course is 16 when I simplify. Now, 4 to the second power is also read 4 squared. So you may see that expression squared, and I'm going to write that in if you can still see that. Another way to indicate a second power is to use the expression squared. A square is 2-dimensional, and the exponent is 2 here. 5 with a 3 up there is read 5 to the third power, which of course 5 to the third power means 5 times 5 times 5, which is 125. Now this is another special one. When it's raised to the third power, we sometimes use the expression cubed. So we say 5 cubed. Now a cube in geometry is a 3-dimensional idea, and so what we have here is to the third power, 3-dimensional third power. They kind of match up that way. Those are the two special ones. They have that extra way of being able to read off the name. Now in this case, this is just read 2 to the fourth power. And it means you have 4 factors right here, 1, 2, 3, 4 factors of 2. And of course, 2 times 2 times 2 times 2 is 16. 9 raised to the 5th power here. I have 9 to the 5th power, but sometimes it said 9 raised to the 5th power. 9 to the 5th power means I have 1, 2, 3, 4, 5 factors of 9, and I got a calculator out to do that one because I couldn't do that in my head. That's why the ink is so much darker. It took me a second. 59,049. Now let's reverse this. Let's take these expressions that are written as repeated multiplications, and let's write them with an exponent. So I have 1, 2, 3, 4 factors of 11, so I'm going to write that as 11 raised to the 4th power. I have 2 factors of 0.4, so I'm going to write that as 0.4 raised to the 2nd power, or 0.4 squared. And this next example, I have got to count them. 1, 2, 3, 4, 5, 6, 7. I have 7 factors of c, so I'm going to write that as c raised to the 7th power. Now we'll combine some material that we learned in this section with a process that we learned in section 1, and that's to evaluate an expression, but these are exponential expressions because we have exponents in them. So we'll still substitute in, and then we'll evaluate. Remember, evaluate means to find the value. That's your key word there. So I'll substitute the 2 in for the n, and that's 2 raised to the 2nd power, or 2 squared, which of course is 2 times 2, or 4. Here I'll substitute the 2 in. This is 2 to the 4th power, which is 2 times 2 times 2 times 2, which we did already, is 16. Now the third one's a little different because I have a factor of 3 in front of the expression that involves the variable with the exponent. This, remember, implies multiplication. So this is 3 times 2 to the 3rd power, which is 3 times 2 times 2 times 2. 3 times 2 is 6, times 2 is 12, times 2 is 24. So this is 24. Now, applications involve a variety of topics, but the first one we'll look at is the idea of a formula, because some formulas involve exponents. Now, a formula is an expression that describes a relationship between quantities, and you get a lot of those in geometry, so I start off with a couple of basic ones from geometry. Area of a square, and there's my diagram of a square, not very good, and the volume of a cube, and that's even worse, sorry about that, but in this case, the square, each of the sides are length s, and the formula is area equals s times s, which is a little awkward to write out because of what it might look like, so we use s to the second power. And remember, area is in square units because it's a two-dimensional idea. The volume of a cube, each of the sides represented here is by an s, the length's s, so volume is side times side times side, or side to the third power, or v equals s raised to the third power s cubed. Okay, again, it's a cube for the way we read off the exponent. It's a square for the way we read off the exponent here. And for volume, it's in cubic units. So I have a couple of quick examples here. You're to find the area of a square with side length 17. So I'm going to substitute the 17 into there. I get area equals 17 raised to the second power. 17 times 17 is 289. Now, I'm going to write my answer in the proper units. Since it's square units and my units are inches, I'm going to abbreviate. I'm going to write square inches. 289 square inches. Now, on the next example, I'm going to find the volume of a cube with side length 5 feet. V equals 5 to the third power. I substitute the 5 right in for the s. So this is 5 times 5 times 5, or 125. Now, because this is volume, it's cubic units, and so I'm going to abbreviate again. My units are feet, so I'm going to write cubic. I'm going to abbreviate cubic CU, and then feet. Like that, I have 125 cubic feet. So with this information, with these notes, and hopefully you've copied this stuff down. I don't want to have to remind in every video that you are to write down the notes. If you didn't, go back, redo the video, and write down your notes here with the examples and your key definitions. Look through them, and you should be ready to do the assignment. And remember, as always, to get good at this, you must practice, practice, practice.